So again, when we factor these, I want you to be able to show me the length and width. Okay, so when I have my rectangular area, I have an x squared area here and a plus 12 here, because we know that those are not, we don't have to combine those as like terms when we multiply out. It's the middle that we have to be able to split up. And to split up the middle, we're looking for two numbers that multiply to 12 and add to 7. Well, those are going to be the factors of 12 at work are going to be 3 and 4. So I factor along here. I'm going to get 3. Okay, factor vertically, I get a common factor of x here, and 12 and 4, the common factor is going to be 4. So these ones we probably don't need to draw the areas out in. Okay, however, I do want you to be able to understand the area, so make sure you're able to draw that area out. Okay, this one here, the area is much more useful because we need to get the split of the middle. And to split the middle up, we want to use that diagonal product. So I know that diagonal product of negative 14x squared. Okay, I know that this along the other diagonal, it has to add to negative 5 because that's how we got this right here. But it has to have a difference. It's got to multiply to negative 14 and add up to negative 5. So the two numbers are going to be negative 7 and positive 2 to give us the negative 5x. Okay, so again, we factor out the common factors. It's going to be minus 2x minus 7. And then the common factors here are just going to be x plus 1. Okay, so then we can put it in our factored form. 2x minus 7, x plus 1. So the last numbers are always going to give us the constant term. And the constant term always ends up is going to be that one there. The constant term is always going to be a product of the last two numbers. So the constant is always a product of the constant in the brackets. Okay, so it's always the product of the constant terms in the brackets. Okay, so factoring these ones here, we want to be able to, this one here again, it has the leading coefficient. So we want to be able to use that diagonal product to help us split that middle term. So we know the diagonal product is negative 72x squared. So the numbers that multiply to negative 72, the factors of 72 that add up to positive 1 are going to be plus 9 minus 8x. Okay, so that's going to give us a 72. So then we need to factor. Okay, the common factor horizontally here is 2. The common factor here horizontally is negative 2. And then here should be 4x and plus 3. So we get 4x plus 3, 3x minus 2. Here when we factor out, we have to make sure we always factor out the greatest common factor first. So we have a greatest common factor of x. Okay, and then when we try to put this into the rectangle here, we know the diagonal product, 12x squared times negative 6. This is the same diagonal product, negative 72x squared. And we need to know which factors of 72 add up to negative 11 or negative 72. So the 8 and 9 don't work, so we can try, what would it be, 6 and 12. 6 and 12 don't work. Then we can try, 3 and 4 and, what would that be, 4 and 18 don't work. And in fact, if we try all of them, none of them work. So at this point, this cannot be factored. So this quadratic is what we would consider prime. Okay, so that's our answer right there. That's the factored form of that particular quadratic. For this one here, we have an xy in the middle. Well, that is consistent with a quadratic, because if I have my area like this, okay, so this is 10x squared, and this is negative 5y squared. If I just work with the variables here, I know I've got to have an x and x here. And to get y squared, I need to have y and y. And that's going to give me xy here and xy here. So the xy, that constant, the middle term xy is the term that we are going to combine together. So the variables match, so then we can just work out the coefficients. So when I do my diagonal product, I get negative 50 x squared y squared. Okay, so then I need to add to positive 23 and multiply to 50. So this is negative 50, so there's a difference. So I should have plus 25 minus 2. And then we factor our common factors out. So they're going to have a common factor here of 5, or negative, that's going to be positive 5. And this is going to be negative 2 along here, or sorry, negative 1. Okay, because negative 1 times positive 5 gives me the negative 5y squared. To get the 10 here, I need a common factor of 2 along here. And the common factor horizontally here is going to be the 5. So that's going to give me my 10x squared. So there's my factored form. 5x minus y minus y. Okay, and then 2x plus 5y. Okay, and if I multiply this together, I'm going to get the variables are going to be match, and my coefficients are going to match as well. So this one here, this is ones that you should start to recognize. These are called difference of squares because I have a squared value here minus a squared value here. Now when I factor that, what ends up happening is it's called a difference of squares because when I factor this out, if I try to put it into areas, negative 16 a to the power 4. These two areas here have to cancel out to be 0. Okay, well that means that they need to be 0 pairs, so they need to be equivalent but opposite. So the only way that happens is, and we can multiply all this together and I get 144 negative x squared y 6 a4. Okay, the only way for these to cancel out is to have this be perfectly symmetrical. So we know that this has to be 3x y cubed here, and we know that this has to be 3x y cubed here, and this length has to be 4a squared, and this has to be 4a squared. Because in order to get the blue and yellow symmetrical, or sorry, equal, this has to be a symmetrical shape. So we know that one of them has to be negative and one of them has to be positive to get that. And that would give us the same areas in the red, the yellow and blue, but one would be positive and one would be negative. Okay, so we don't really need to draw out this picture each time if we recognize the difference of squares. We know it factors to a plus b, a minus b, okay, which is going to be 3xy cubed plus the square root of that is 4a squared, and then the conjugate, or the opposite, 3xy cubed minus 4a squared. Okay, and again, the reason why it has to be like that is because we have a square and a square here. The middle term has to cancel out, so we have to have symmetrical diagram here for these to cancel out, and it has to be a square shape. Okay, so we get this, and this length have to be matching but opposites.